So fine, guys. It's all about the quick revision on the Waec chemistry questions and the predicted questions. Like I do say, they are predicted questions. They are not the live questions. So I am engineer. You all know me very well, and this is all more about like talk show chemistry. It's kind of straightforward and not too difficult for those of you who actually knows it. For those who are still struggling with it, you can just listen to this simple talk show. I'm going to be taking you around five sets of questions, which I'm not going to be too fast. You can just listen to it, record the class, and as well put into consideration some certain points about concept that I will be talking about. I think it's important for you. If you're yet to subscribe to this channel, you can do that. This is the modified channel. The other channels are also available. You can search for the same name. For those of you doing physics, especially all the high school physics, are available on that physics channel. So guys, no time to do advert. I have just 1.5 to 2 hours to do this, and I'll do them one after the other. The first one is we have to state two advantages of synthetic polymers over natural polymers. Fine. So from the word synthetic, you know it's artificial. Polymers are generated from combination of two or more monomers. Elementary class, you have studied that, I believe. So, and they are classified into two. There are different ways of making polymers: addition, polymerization, and condensation. But I will limit myself with what we have before us. I will only talk around other things because I want it to be fast. Because if I continue to talk about chemistry, it's going to waste a lot of our time, and I don't want us to sleep on bike. So let's see the first one. We are talking about some advantage of artificial polymers over natural polymer. So anything in chemistry, when you have to state advantage of something you can produce yourself, you think about the cost. I do say that in offline classes. Cost is the first thing. So you can say one, it is cheaper. So I always love student keeping to my ways because it is going to help you. It is cheaper. You can talk about the strength, that is durability. Artificial polymer, which is synthetic polymers, are durable. So you are just to mention two advantage. But if you want to talk about more, which is the most important thing you have learned from your new school, chemistry, you are talking about synthetic polymer recycled, can be recycled. So that's another important point. You can keep that in mind. Can be recycled, can be recycled. So I'm going to be managing space because I don't want to create any extra page or pages as the case. So we move in sequence to the next question. So I say you can write it is cheaper, it is durable, can be recycled, blah 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 blah. You can even write about the availability, easily available, and so on and so forth. You only to write two according to Waec, easily available. So this is some important thing. Just write any two that is convenient for you. You don't need to waste your time. So the next one is B Roman figure 1. You are to draw the structure of a product formed when 1 mole of ethyne react with 2 moles of hydrogen bromide. So it's a kind of reaction in which I think it is common. You guys know addition reaction is common to unsaturated hydrocarbon. So basically, the product that will be formed, if you followed my organic chemistry class on my chemistry page, you wouldn't have issues on this. So ethyne is C3H4. You guys know it very well, combined with 2 moles of hydrogen bromide. So it's an addition reaction which is common to unsaturated hydrocarbon. Without wasting time, we know it's going to give us CH2. We have CBr2, CHBr2. That is the way I write it. This is the product, but according to the line of the question. So according to the line of the question, we are to draw. So I'm not to write this equation. So it is not needed for me to write the equation, just for the sake of understanding of addition reaction of alkynes. That is basically unsaturated hydrocarbon. You know, it's going to give you alkanes, then finally alkane. We can try to draw the Markov-Nikov rule and stuff like that, but this is Waec examination. No need of wasting time. Direct combination reaction. This is what you are going to have, and that is the final product. So drawing that out, without any further ado, we can say CC. It is simple to draw now. There are two H's, can put it like that. It should be CH3, not CH2. It's not balanced. That is why when you draw, you spot your mistake. H, H, H. So the second one we have H. You have Br and Br. So this should be CHBr2. So this is it. This is the structure you were asked to draw according to the examiner. So B Roman figure 2 says, name the product form in 1B1. So the product form is just a single product from what you can see. And this product is called, you can see from, you guys know how to name all this. It's very simple. This is one separate numbers by comma. 1, comma 1, you know that. Hyphen, then dichloro. I said dichloro, dibromo, not chloro. Dibromo. This is dibromo 18. So that is the product form from reaction of ethyne with hydrogen bromide, 2 moles of hydrogen bromide to be precise. So that is that. I think that is more like a cheap question for us, and that is why chemistry is cheap, especially for Waec. Chemistry is very cheap and direct. The C part of the question says you are to explain briefly. You can see just a brief explanation. Examiner is not disturbing you why benzene is soluble in ethanol but insoluble in water. I think this is more like what you've learned also in your introduction to general organic chemistry. When we want to introduce you to general organic chemistry, we introduce you to all these type of what we call different solvent, polar solvents and non-polar solvents. So the characteristics of chemistry is for students to understand the fact that you should be able to understand reaction mechanism. For O-level students, for this Waec sake, it is only the basics, the peripherals that are needed. So you don't need to know too much of things. And that is why I do say Waec examination is very easy to pass to get your A1 and stuff like that. If you follow the line of your syllabus, I don't think you should have any problems doing anything with respect to chemistry for basic level. So then we can quickly take it. I've said it all. The reason why benzene is soluble in ethanol is for you to understand that benzene, both benzene and ethanol are organic compounds. Benzene and ethanol, both of them are organic compound. So you should know that basically it means what? While water, everybody know water is an inorganic compound. Inorganic compound. So basic way of thinking. So when I say inorganic compound, you've learned down that your chemical bonding in elementary class, I think year 10, SS1 to be precise, you were told inorganic compound, you call them, okay, example of inorganic, H2O, water. It's an example of what we call polar compound or polar solvent. So you can keep that in mind, polar solvent. So keep that in mind. It is a polar solvent. So always keep that at the back of your mind. So another reason you can just write what I'm trying to say is that because both of them are organic compound dissolve in organic solvent. That is what I'm trying to say in a simple man language. So you can also write it in that format that organic compounds, just for understanding's sake, dissolve in organic solvent. Organic compounds dissolve in organic solvent. Organic compounds will dissolve in organic solvent. So you should keep it in mind so that benzene is insoluble in water. So benzene is insoluble in water. So I'm not going to talk about hydrophobic or whatever now because it's beyond the scope of your syllabus. I will only limit it to respect to Waec. This is what Waec need, and that is why the word briefly is stated. So you have your 2 marks there. Nothing to waste time on. The next says, let me change to red. The next question says, list, please, let's follow the line of question. List 2 laws of chemical combinations. So there are about 4 basic laws of chemical combination you have studied from year 10. I believe you still remember that very well. So you are only to list just 2. So you can just list any 2 that comes to your mind. So the laws of chemical combinations are, one is law of conservation of matter, law of conservation of matter. Everybody knows that. Please, you should be careful in physics. Law of conservation of energy, law of conservation of matter are basically 2 different things. So law of conservation of matter, I will just list because of space. We have law of constant composition. That is definite reaction. Constant composition. So another one we can also talk about is law of multiple proportion. My space, law of multiple proportion, and you can also talk about the fourth one. There are 4 law of reciprocal proportion, but I'm not going into that. So you might be asked to state any of these law. It is one of the most important aspects of chemistry too, in under your topic of introduction to chemistry. So conservation of matter, everybody knows. For all chemical equations, chemical equation must be balanced. So matter can neither be created nor destroyed, but can be conserved from one form to another. Constant composition. Basically, in your objective, they might ask you another name, definite proportion, or pure sample of the same elements, have the same mass combined by the same proportion. So law of multiple proportion, when 2 elements combine to form more than one compound, the fixed mass of one combined with the variable mass of the other are always a simple ratio. I am not here to state any law for you. I'm just here to let you know important things you are going to see during your examination. So by and large, what I'm saying is that candidates must be very careful about all these elementary things, chemical bonding, organic compounds, reactions, actions and reaction, chemistry of actions, all these, you cannot run away from them. So that is why it is important you watch this video to the end if you desire to have your A plus or A1, the way it is being called in Waec. So now we can look into the next one, Roman figure 2. Now, I think it's time for me to write beside the stuff because of space. So they are just to list that you have to state the half-bow principle. Now, this is also going to come out this time around. It may not be half-bow, it may be Hund's rule. You just need to know all these stuff, Hund's law of multiplicity. So your aspect of Schrodinger equation, don't let me go into details. Like I said, this aspect of your electron filling and stuff like that are very, very important. Please, you need to know it. That is energy quantization, blah, 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 blah. So about alpha principle, I believe you know that if you are good in configuration, because you cannot write a WAEC exam without configuration. So configuration is simple. I told you it is more about talk show now, but these are simple, simple things. So talking about alpha principle, that is just talking about arrangement of electrons with respect to their energy levels. I have videos on alpha principles online, but for now, you are doing revision, you can just learn everything just in one shot. So alpha principle, we can just quickly write any language. One thing about WAEC is I mark chemistry and mathematics WAEC. I can tell you what is always needed when it comes to writing. So chief examiner allow you guys to use a different language or languages as the case may be, in as much that what the major word is not missing. So you have to keep it at the back of your mind. Stating our verb principle, just I don't think everything here is format. Includes the law of chemical composition, because you can't just say our verb principle is format. I would have said that is just too cheap. So we can just say you can say our verb principle states that the way you want to write your English. electrons occupy orbitals. Orbitals are just regions or space in which electrons occupy. So electrons, that is my own definition, electrons occupy orbitals in order of increasing energy. In order of increasing energy. In order of increasing energy. So keep that at the back of your mind. So you can write it in any form. And you have been told, I believe your teacher has actually explained this, talking about the lowest energy level. We call it the N plus L rule. 1s, then you go to the next one, 2x and 2p, and 2s, 3s, 3p, 3d, 4s. Then the arrow will now go like this. You know what I mean? So 1s, 2s, 2p. So it is just the NLMS, that is your orbital. You know them very well. And if you don't know, they're talking about the quantum number, principal quantum number, azimuthal quantum number, magnetic quantum number, and the spin quantum number. I think for your level, you should be careful about what each of them starts, what the purpose of each of the quantum number. Talking about the size of orbital, principal, the shape of orbital, the shape of orbital, the orientation, magnetic, and the spin. So, and you can also just learn about the shape. Because sometimes you can be asked about orbitals, the SPDF orbitals, the shape of each of them. S is a spherical, P is a dumbbell, D is a double dumbbell, then F is said to be what complicated. So these are things in which you can expect in your objective set. It says talk show. I'm going to answer 5 sets of different questions. This is just the first slide. So I need to increase my pace. So I can talk about all these things on and on and on, but let me limit it to what I have here. But I will always love to take you through some other things which I predict it's going to come on. So having said that, the E part says you are to explain briefly why the first ionization energy of aluminium is atomic number is 13, is less than that of magnesium, which has an atomic number of 12. Everybody knows aluminium and magnesium. So you can just write the old school configuration. Look at this. Aluminium is having an atomic number of 13. We all know that. So if we write that, talking about the numbers of share, that is 283, right? So the new configuration, that's why I said you can't do Waec exam without configuration. 1s is the lowest, power is 2, 2s 2. I hope you still remember this. You can quickly study that. If you have forgotten, do a quick revision on configuration. Definitely you are going to write. This is 10, then 3s2, then 3p1, right? That is aluminium. So for 12, which is 12 here is a magnesium. Magnesium is Mg. Atomic number is 12. We write atomic number under. Mass number is up. Mass minus atomic number is the number of neutron. You know all this. This is very important for Waec exam. Because focusing on the tough aspect does not mean we should not learn the basics. Please note that. This is 2H2. The same thing, only that you are going to see that this guy is going to end here. So this is 1s2, 2s2, 2p6, 3s2. So I just want you to see why the first ionization of aluminium is less than that of this. If I've written the configuration, it's very easy to predict. It's very, very easy to predict. Now, there are 2 ways in which you can say this. It depends on how you want it to be. You can say here. You can say here, look at this. The 3p orbital of this aluminium, or the 3p electrons, are farther away. I hope you are getting it. Are farther away. So when something is far away, what we say is that what the force, the energy that is holding them is very, very weak. Now, here, the 3s orbital is closer than 3p orbital. I'm talking about the arrangement now. In elementary class, let me try and demystify it more so that everybody will get what I'm trying to say. The basic knowledge we have learned is electronegativity or ionization energy increases across the period. I believe you know this too, because it's important you know. Increases across the period. Now, the reason about that, there is this type of thing we always talked about. I'm focusing on this. Please watch my mouse here. Is that we're talking about the distance between what we are talking about, the energy that is required to remove. So there is a lot of energy that is always involved. So now another person can say the outermost shell in aluminium, which is I think it's easy in this way. Outermost electron in aluminium is at the 3p, whereby the outermost electron in magnesium is at the 3x. As you can see here, this is the outermost, this is the outermost here. This is why I have to write the configuration so that we can all visualize. So now because of that, the 3p, this guy, the 3p subshell of aluminium, this particular one, is farther away from the nucleus than the 3s. So the 3p is very far away than the 3s. And because of that, you know what I mean by that? That means the ionization energy of aluminium is less than that of what? That of magnesium. So what I'm trying to say in essence is what? The more farther away, the less what? The less stability. The more they are close to their nucleus, the more stability. Do you understand? So this one has the 3p, which is farther away than the 3s. So you expect 3p, the one that has 3p orbital as its outermost electron, to be less stable than that of what? 3s. So in language form, you can just write what? The outermost electron of the 3p orbital of aluminium is farther away than the outermost electron of the 3s of magnesium. Hence, aluminium is less stable. And that is the reason why by what? Ionization energy of aluminium is less than that of magnesium. I hope you understand. Ionization energy increases across the period. That is what you are being told in your junior classes. And that is the explanation to it for your level now. So I think that is not too bad about that. Then the next question is just one of the questions that you guys are going to see, one of the most important questions for your exam. You can always keep it in mind. I think we talked about it when we did first set of questions. This says that we are to state the type of reaction between bromine and propane. So I talked about it the other time. You can keep it in mind. Propane alkanes generally undergo what we call substitution reaction. Alkanes undergo substitution reaction. This is basic substitution reaction. Otherwise, alkenes and alkynes undergo addition reaction. So just use that as a point of reference. I think this is direct for us. Because of time, I'm taking my time too much on just first slide and still have 4 more slides. And so, guys, that is that about that. I hope you understand this. I just hope so. And that is just that about that. Let's go to the next slide. Wow. So the next question, which is part 2 of 5, we are to define van der Waals force. Do I need to waste time? Let me just be doing it by the side directly so that we don't have issues. Everybody knows definition from your from your textbooks and your teacher's explanation. Weakest force of attraction, which can also be demystified into 2 forms. You know them, the dipole force and stuff like that. But I'm not going to that. Let me just focus on the questions for now. So we can just say van der Waals force are weak. They are weak intermolecular force. Weak intermolecular force. Intermolecular forces or force. Anyhow you want to write it. Of attraction. Of attraction. They are forces of attraction between molecules. Please note that between just molecules, because I have to increase my pace now, or atom. So this is that. That is the definition of van der Waals force. So this is also very important. Chemical bonding, you cannot run away from it in Waec question. You have to list 2 factors which will favor the formation of each of the following compounds. Covalent compound. Wow. We talked about that in the previous question. Covalent bond, you guys know it involves sharing. No, so I'm going to talk about covalent bond. We've talked about the type of what factors that affect bonding. Bonding are more like understanding the periodicity or the periodic table, how elements bond together. That is talking about 2 major factors. Understand? That's the difference in their what electronegativity or the difference between their ionization energy. We are talking about covalent compound. Please note that the difference between, so we are just, we need two factors for each of them. Covalent compound, it involves sharing. So the more the ionization energy, we talked about it not quite long. Ionization energy, the more the covalent bond, and the more what we call the electron affinity. Definition can be asked. Electron affinity, the more the covalent bond. So these two factors affect the nature of covalency of a compound. So ionization energy, electron affinity are two factors that affect the nature of covalency that is formed in a compound. The next one is dative bond. I hope students know dative bond. Dative bonds are also called coordinate covalent bond. So talking about that, you should definitely know that it's a mix of these guys, the combination of what we have listed now. So we can talk about dative bond. The first one you can think about is you can think about to form dative bond. From the example, you can think about the ability of what we call a lone pair. You don't want to start explaining VSEPR. You don't need it for now. So lone pair electrons, some of you know what I'm talking about. The lone pair electrons. So if that particular element participating in what? In that bonding has a lone pair. So it has the tendency to form what we call dative or covalent, coordinate covalent bond. Another thing is if it has the tendency of having what we call empty orbital, empty orbitals. Or basically, most of your textbook will say vacant orbital. So anyhow you write it, I think that is very important. So we have example, you know them. The one given directly in your textbook for your level, ozonium ion and NH3 plus, and NH4 plus, or you say NH4Cl, Al2Cl6. I don't want to start mentioning. No, only one element is what particularly is involved in sharing. Note that during coordinate covalent. So that's that. Don't let us waste time because time is not on my side again. So I have to increase the pace. So apologies, apologies, apologies. So B part says consider the following pairs of bond. So we have carbon combined with nitrogen, carbon combined with hydrogen. The same carbon is combined with oxygen, and carbon, nitrogen, carbon, fluorine, carbon and fluorine, then carbon and oxygen. So let's see. What I know now is that we are talking about a kind of bond, which we want to just use our concept of hydrogen bond. I'm very, very sure about that. Let's see which bond in each pair is more polar. Which bond in each pair is more polar. So now the next one say arrange the bond in increasing order of their polarity. I think you just need to understand the concept of what we call hydrogen bonding. For example, we say the order is always FON CH blah 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 blah. FONC means fluorine, oxygen, nitrogen. That is talking about, you can see I'm moving across the period. So now FONCN, FONCL, H, whatever, like that, S, and like that. So fluorine, oxygen, nitrogen, carbon, you move in that. So now to explain this, you have to consider the following pair of bonds. Which bond in each pair is more polar? So talking about the polarity. So we can say the bond that is more polar between these three, one, two, three, each of them, please, is N, because I have O, look at this. I have nitrogen, hydrogen, and oxygen. So in this case, if I'm to arrange them in order, it should be Cn, then to CO, then to CnCO, then to CH. So please follow that order, Cn to CO, then to CH. So then the second one says, I am to arrange the bond in increasing order of polarity. Just the opposite of what I've written here. So I have increasing order. That is from lowest to highest. It will be from CH, and from CH. I think I am taking them in this place between CN and CH. The first one says which one is more polar. CN is more polar than CH, because somebody is sending a question to me now that he doesn't get what I'm doing. So CN is more polar than CH. Then between CO and CN, CO is more polar than CN. So that is why I've written this for you. Then the last one is between CF and CO. Okay, between CF and CO. So this is what you are saying. CF is more polar than CO. So I've given you the order. So just use this order to always get your answer. And these are answers for each of them. That is what we are doing. So the next one, also, we should arrange the bonds in increasing order of polarity. So I just follow the order of what I have. So I will write CH first. You can put the hyphen there. Then followed by, we are writing in order, it will be less than. So it will follow by CN. Then it will follow by CO. Then it will follow by CF. So that is the lowest, then followed by this guy, followed by this guy, followed by this guy. So you know the reason, because hydrogen is basically said to be in group 1 of the periodic table, though it is very highly reactive. So you just need to note that. So that is that. This is what the examiner wants for Roman figure 1 and Roman figure 2. So keep that in mind. And the reason for this polarity stuff is based on their what? Difference in what? Electronegativity. That is the concept I have used. But because of my time, that is why I have to just what? Increase the order of what? The pace of my solving. So the next is C. About question C here, we are to arrange, okay, consider the following pairs of elements. Beryllium is having atomic number of 4, and magnesium is having the atomic number, this is capital M, atomic number of 12. So what are we to do? We are to give the electronic configuration of each element. Basically, you cannot do without this. I told you, I think this one is easy for everybody to write. So beryllium is 1s2 number 4 and 2s2. Whereas the second guy there is, I think we've written magnesium before in the previous slide, 1s2, 2s2, 2p6, and 3s2. So this is the electronic configuration, which I believe you all can write from the Aufbau principle. And then the next question says, we are to explain briefly why the elements have same chemical property. I believe you guys know the reason for this, where they have the same chemical property. You can always say because of what? They have the same number of what? Electron in the outermost shell, because they belong to the same group in the periodic table. All those ones are acceptable. You can write that. So you should always have that at the back of your mind. So the major reason is that because they have the same number of shells, have the same number of shells, or outermost shell, or outermost electron, or have the same numbers of electrons. I say shell. Valence electrons. If I have written shells, that would have been very bad. Valence electrons. So E minus electrons. So that's that. Then the next one says, arrange the following species in order of decreasing size. So decreasing size, neon, Na plus, Mg2 plus. You can see what I'm talking about. Sometimes Waec can ask you some questions that are about your brain. These are what we call ISO and electronics. Neon is number 10. You were told that atomic number. Na plus is also number 10 because it has given 1 electron. So then we have Mg2 plus is also number 10. So, but you have to arrange them in what? In order of their what? Decreasing size. Decreasing size, that means from highest to lowest. So I will use Fajan rule, which I've explained also in one of my video online. You can check my chemistry channel. But it's also very simple to explain ISO electrons, if you want to explain them, you know, each of them has the same number of what they have the same atomic number now, so they are isoelectronic. They have the same numbers of electrons. You should not understand that. So now we are going to use the Fajan rule, which says that the bigger the size of the species, the smaller the what? The nuclear charge. The bigger the size of the species, the smaller the nuclear charge. So if I'm going with that, it will be Ne is greater than Na plus, then is greater than Mg2 plus. So I think this is very direct to understand from what I said. So always have the smaller the nuclear charge, the bigger the size of what? That particular element or the species. The smaller the nuclear size, the what? So for example, that is the law. So this one is like the charge here is 0. So it will have the highest size. That is what I am doing. So we are arranging from highest to lowest. So this is 1 and this is 2. So it will be, this is the biggest, follow 0 as the lowest charge, followed by this, followed by this. So that is the concept behind size. Please note that when you have what? Isoelectronics, you can also have this in what? Under your topic of isotope. Isotopes, isotones, isoelectronics, and isodiaphers. But for now, for your level, I think it's isotones and isotopes and isoelectronics that you can only see in Waec. For those one doing JUPEB and the A-level stuffs and the IDMB are those ones that will be faced with those other part B of the Fajan rule. So for now, keep it in mind, the size of an electron or the size of what isoelectronic varies. For the one with the lowest size, we have lowest electrons, we have the highest size. So based on that, that's the nuclear charge principle. Now the next is I'm wasting too much of time. I have to increase my plane. Now they say we should explain the answers to this. So and the explanation to that is what I have given just now. That's what the explanation is. What according to Fajan rule, you might write it like that: the bigger the size, the smaller the nuclear charge, the smaller the nuclear charge, the bigger the size of the species So that is that about that. So then the last question for this page is the D part. We are to define transition method. We can define transition method. Let's do that. So transition method definition. Now we can define transition methods in different ways. Depends on how you want to define it. But let's just keep this in mind. You can say transition elements or transition methods or whatever, they are elements. Transition elements are elements. They are elements with partially filled d orbitals. They are elements with partially filled d orbitals. So you can also define them in your own way. You understand? Or you can say they are the one in which cations are incomplete in their d orbitals or incompletely filled d orbitals. So the next one says, let's be fast, please. Explain briefly why most transition elements have variable oxidation state. It is very, very simple to explain that one. The reason is owing to the fact that you can just write in language form. Most transition elements have a variable OS means oxidation state because I just want it to be fast because they use their 3D or 4s electron because let me just put in language, they are 3D/4s electron are used to form bonds. Apologies. To form bonds due to the closeness, due to their closeness of energy of 3D and 4S. So the major reason why they have variable oxidation state for most of them is because it is their 3D and 4S orbital that an electron can easily move from one 3D orbital. We can take a variable with a lot of example between when we talk about copper, which is the closest one. You can see from the first 30 element. As you can see, copper 2 plus, and ordinary copper, stuff like that, iron 2, iron 3. All these are because of their 3D and 4S. When we write the configuration, what we notice is what the closeness between those two energy, 3D and 4S, is responsible for the movement of the electron. So they can easily migrate from one to another to form what? The octet, and obey the octet tree, which you have studied in your junior classes. So that is what is responsible for their variable oxidation state. And the last question here, which I will manage in front of it, because I want to go to the next page for the next question. So it's give 2 uses of metal. I think this is more like a bonus question for every one of us. So for metals are used for, they are used in making of automobile parts. Most metals are used in the making of what? Aluminium sheet, or you say in making of tin foil. Metals are used as reducing agents. They are used as for electrical wires. They are very important in the use for electrical wires, for making of bridges, for alloys. Metals are used in preparation of alloys. You know, you have a lot you can write. So just write any two. Preparation of alloys. Just trying to write important ones. I think for anyone you are writing, it's going to be marked by the chief examiner, because you have different for roofing sheet. That is one thing you can see in your Babio as well. For making of nails, aluminum foil, musical instruments, electrical wire. For making of alloy, they are used as reducing agents. You know the reason why they are used as reducing agent. And you know, non-metals are used as oxidizing agents. Those are other things in which you can keep at the back of it. So in sequence, I think we move to the third question. We are almost getting there. The third slide. Yeah, fine. The third slide is basically another important aspect, which is aspect of salt and preparation of elements, metals and non-metals and their compounds. So you can't run away from these two. Definitely you are going to have questions on them. I don't want to waste time, and some aspect of little about documentary, stuff like that. I think that is what question 3 is basically mostly about. So let's look into it together. And this time around, we are going to up our pace. We are going to up our pace. I think it is what you can do on your own. Explain briefly each of the following separation techniques. Wow, separation of salt, crystallization. So how do we do that? So we are just to explain how salt is being obtained by crystallization, which is also called precipitation. Double crystallization is also called precipitation. So the process that we employed in crystallization, I think I've done a lot of quick revision on chemistry that I've explained how salt are being crystallized. It is just process of eating. We eat the what? Eat the salt. Then cool it to obtain the crystals. So I've explained even with our physical situation example on the concept video I've done. Crystallization is just a method of what? Of separating a salt. When you have two salts, you are going to heat them to a particular temperature, or say you are going to concentrate the solution, heating it to allow it to cool. Then after cooling, then you obtain the crystal.
So, but when it comes to evaporation, everybody know how to evaporate from a state of matter. This is what you eat the solution. Eat, then the solvent escape into air. The solvent escape into air. So everybody knows solute is left behind, right? Solute is left behind. So this is evaporation, then crystallization, you eat, you pull, then you obtain the crystal. The third one is filtration. Filtration is a simple method. It's just to actually pouring of mixture. When you have mist, you know all these stuffs. Pour the mixtures into a filter paper. So then the liquid passes through the filter paper and residue remain. So I just do it in simple language because you have to explain briefly. Residue remain on the paper. So these are just little things in which you can be asked: crystallization, evaporation, and filtration. So the next one is we have to list 3 characteristics of halogen. Halogen and their compounds fall under the topic of metals and non-metal. I am doing B1, characteristics of halogens. Everybody knows all halogens are diatomic. All gases are diatomic. All gases are diatomic except noble gas. You can keep that in mind. I don't want to be talking too much. One thing about me is that if I take chemistry, you see chemistry is very simple for this Waec. I don't think it's something we should have problems. All gases are diatomic. Another thing is what? They are all non-metal. Periods. Group 7 or group 17, you expect non-metals. Halogen are non-metal. They are highly electronegative. They are what? They are all what? Oxidizing agents. They are oxidizing agent, all of them. Fluorine, bromine, iodine, and astatine. Oxidizing agents. They are highly electronegative or non-metal. Anyhow. So we have to list 3. You can write more than 3. We can also say they form covalent bond with non-metal. Forms covalent bonds with non-metal. They are also non-metal. So they form covalent bond with non-metal. Another one is definitely they are held together by van der Waals forces. We've talked about that the other time. They are very reactive, and they are also what? They are also what? They form color. They also are, they all have color. You know the color of chlorine, you know that of bromine, you know that of iodine, and you know that of fluorine. So fluorine, bromine, chlorine, iodine are the major halogens that are found in the world, group 7 or 17 of the periodic table. So let's keep that at the back of our mind. The next is write a balanced chemical equation to illustrate the reaction of cold dilute NaOH with fluorine and with chlorine. Now, this is a kind of reaction that I think is very common. What we call a kind of a disproportionation or disproportionation reaction. Fluorine undergo what we call this, more like a redox reaction. No variable OS, variable oxidation state. So when we react sodium hydroxide with chlorine, it's actually give us 2 different what? 2 different we have 2 different products. When the NaOH is cold and when the NaOH is hot, we have 2 different products. We have what we call sodium octochlorate and sodium trioxochlorate. So students need to keep this aspect. This is one of the most important topic under your non-metal and its compound, halogen and its compound. So be careful that when you are reacting with cold, it will give you an oxochlorate 1 acid, oxochlorate. But if it is with hot, it will be trioxochlorate. This is just the fundamental. Please note that. So if you've written with chlorine, you should be able to write with fluorine. So I don't think you need to waste your time. Now, let's see. The first one says we should react with cold dilute NaOH. Now, the concept here is that, out of all halogens, you just need to learn concept. It's important. Fluorine is said to be the most reactive. Abi? F2 is what? The most reactive halogen. Now, because it is most reactive, please note that it does not react with cold NaOH. Please note that. That is an exception, which I do teach in offline classes too. It's an exception. So F2 fluorine does not react with cold NaOH. The reason is what is highly electronegative and it's what very reactive. So it does not react with NaOH in cold form. So the reaction for this one does not occur. You can say no visible reaction, no reaction. That is just what you need to write. Or reaction cancel out, cancelled. Anyhow you want to write is accepted. But for chlorine, like I said, if it is chlorine is written as Cl2, all halogens or all gases are divalent. It's combining with, you can write the state of matter, which is gas, combining with sodium hydroxide. Sodium hydroxide is aqueous. I told you the major product is what you need to write. Basically, everybody can see NaCl, which is the salt. You can see water and what? Sodium oxochlorate 1, NaOCl or NaClO, anyhow you write it, plus water. So this is what we're talking about. You can write the state of matter. This guy is aqueous. Wow. This is aqueous. This is aqueous too. And water is liquid. Let's shift this thing back up here. Yeah, water is liquid. So that's that. You have to balance chemical equation. It is important. I always balance oxygen first. Chlorine is 2, chlorine is 1, plus 1, that is 2. So sodium is 1. Oxygen is the only problem here. Oxygen is 2. So if I put 2 here, sodium is 2, sodium is 2. I think it is balanced. So it is balanced like this. Yes, it is. So that is the reaction you have to write for this. The next one says, give one difference between a gas and a vapor. Oh, wow. So we can always do this in our own way. That is one thing about chemistry. Now, a gas and a vapor. And that is another thing where students cannot make difference. They cannot actually differentiate between evaporation and vaporization. If you know how to differentiate between that, I don't think you should have any problem with that. Now, we can say a gas is just a single physical state, whereby vapor is what? A mixture of what? Of a gas and liquid. I think that is better. So always keep that in mind. And another way you can say, which I think is very simple, is that it is what? A vapor that condenses to gas. So that's just, you understand? I think that's why I say your own way is always very important. So vapor condenses to gas at high temperature. So that means gas is a physical process which consists of a single phase, whereas vapor refers to what? A substance with a mixture of gas and liquid. So vapor is a mixture of gas and liquid. Another way. And liquid. So I hope you understand. These are why you need to understand concept and not just cramming the textbooks. The next is state one condition under which a gas exhibits ideal behavior. I think both in our physics and chemistry, we talk about ideal gas and real gases. So we said ideal gas occurs at high temperature, everybody knows, and low pressure. Please note that. Everybody should know this. High temperature, low pressure. Only one is what you have to state. I am only stating this because sometimes you may be asked to state more than one condition. So that's why I'm always stating more than one. So high temperature and low pressure gases behave like an ideal gas at high temperature, but it deviates to behave like a real gas at low temperature and high pressure. So you can also say high volume. Please note that, or light volume. That's another condition. You can write it. So large volume is also a condition you can keep in mind. So the next one, my dear student, is calculation, which basically we have to what? We have to what? Solve. The next one says magnesium of mass 1.2 gram react completely with chlorine. This is chlorine. Write a balanced equation with magnesium and chlorine. Oh my God. Magnesium is solid, Mg, combined with chlorine is Cl2, is a divalent gas. To give us magnesium chloride, everybody knows from concept of bonding, MgCl2. Magnesium chloride is also solid. You can balance the equation if it is not balanced, but I think one more combined to this, that is 2 moles. So looking at this, my dear students, the first one says write a balanced equation, done. The next one says calculate the volume of chlorine at STP. I don't think we have to waste time. From stoichiometry, I've done that many times on my channel. And if you are just joining, it is still not a problem. Of chlorine, you can see 1 mole of chlorine, number of mole equals to volume over 22.4. I hope students know that. But before you can do that, you are going to molar volume of a gas, MVG, is always 22.4. It will be given in the bracket. You can see molar mass of magnesium is this, and chlorine is 35.5. From here, 1 mole of this guy liberates 1 mole of this. We have learned from, there are different methods, but let's just use the formula one, because most of you like formula-based question. Yes, I know most of my students will prefer formula-based. So let's use formula-based. Number of mole is mass over molar mass. Numbers of moles is equals to the mass of the substance divided by its molar mass. I hope you understand this. So if we go by this, mass of this substance, magnesium is mass of magnesium is 1.2. Molar mass of magnesium is 24. On simplification, you have the answer to the number of moles here. I am not going there. So, but we can see that 1 mole of this guy liberates 1 mole of chlorine. So we can use the same number of moles for them. I don't have calculator here, but I can use my concept of mathematics to know that if I divide 12 by 24, basically it's going to be 2. So then I have 1.2 divided by 24. I know it will be 0.05. So which is simple for me to get. So your calculator is allowed for you guys. So if 0.05 mole is required for this guy, the same is 0.05 mole will be required for that guy because they are combined with 1 mole. So you use the second formula of stoichiometry, which is numbers of mole equals to volume over 22.4. So numbers of moles is equals to the volume over 22.4. You can keep it in mind if you don't know. So in this case, you are looking for volume. So volume will be numbers of mole times 22.4 from cross multiplication. That means the numbers of mole is 0.05 times 22.4 and directly 1.12 decimeter cube. It will be the answer to this. These questions are common in your objectives, so you will definitely see them. Now the next one says, define each of the following times. Atomic number. We can all define the atomic number as the numbers of protons of an element. And if you want to define it in another way, it is also acceptable. So note that. So atomic number is the numbers of protons, the numbers of protons or electrons present in an atom. Numbers of protons present or in an atom. The next one is mass number. To define mass number, we know it is the combination of protons and neutrons. It is also called the nucleons. Please note this because of your physics. So it is the numbers, you write it in full definition of protons and neutrons of an atom. So all these are common. You cannot run away from them. Definitions are very important in chemistry. I hope my students are getting this. And that is that about the third question. We are going to the fourth question. And the fourth question is this. So we are looking into the next one, which is the second to the last page, as I've said. We have 5 pages to talk about, and this is basically on hardness of water And we can do that together as well. So we can define as water that does not form lather with soap. Now I need to increase my pace. So that I've now used exactly 1 hour. So we can just use the remaining 35 to 45 minutes for the rest of the question. So water that does not form lather with soap is called hard water. So I know everybody should know this. So water that do not lather easily with soap. That is hard water. Now, about hardness, they are categorized into temporary hardness and permanent hardness. So we have to state one sort that causes temporary hardness. It's very simple. Temporary hardness basically are caused by carbonate of magnesium and sulfate of calcium. So you can say magnesium carbonate or magnesium bicarbonate. The way we write it, MgHCO3 all twice. So you can also write, if you don't want to write that, you can also write any other thing. It's not necessary you write only for magnesium. You can write it for calcium bicarbonate also, CaHCO3 or twice. So, and for permanent hardness, you know, it is the sulfate and the chloride. I do tell students in offline classes that carbonates are responsible for temporary hardness, important fact, and chlorides and sulfates are responsible for permanent hardness. So once you have this in mind, then you know basically the cation present are basically calcium and magnesium. So those are the cations that are formed in what? Hard water. So for the next one that asks for permanent hardness, you can just write any convenience, at your own convenience, any two. So if I'm the one under this, I can just write calcium chloride. I can write CaCl2. I can write magnesium chloride. You can write magnesium sulfate. This should be capital MO places because I'm managing space. You know how to write. All these things are very important for you to have your full marks. They are very, very important. So now, be that as it may, we'll go to the next one. We are asked to give two methods by which permanent hardness could be removed. I think this is also very, very important for us to keep in mind. Permanent hardness can be removed by what we call permutate method. I think it's common. Teachers love to take permutate method. My word. Which some of your teacher call zeolite or your textbook or iron exchange by using ion exchange dressing. So all these things is either permutate ion exchange or you write ion exchange. I never write that. Ion exchange dressing. Anyhow you write it, I think it is. Then the basic one is washing soda. You guys know washing soda very well. That is the use of Na2CO3. So note that. Then you can also write fractional distillation, which I think it's kind of popular also in secondary school. Fractional distillation. So I said by adding Na2CO3 is also another method. I don't want to say too much. So you are just to name just any two methods, any of the two. So once I've written more than two, it's very simple. So the method is we dissolve. If you want to know what they call permutate method, I have it also on my full course chemistry, which I did with an interactive board. So it's available on my other channel. It is just the mixture of calcium sulfate plus sodium hydroxide. So when you mix calcium sulfate, I'm not going to much of the details. Calcium sulfate plus sodium hydroxide. That is the process we call the method we call permutate method. So you know what you are going to calcium hydroxide plus Na2SO4. So that is that, whereby that Na2SO4 is used to remove what? The agma. So Na2CO3 is called washing soda. So washing soda. So adding of washing soda is one of also the fundamental methods. Fractional distillation and by the permutive method. So washing soda naturally is going to be mixed with the magnesium sulfate or magnesium chloride or whatever, iron chloride. Then when you mix them together, you are going to what? Reduce this to sodium sulfate and the rest. So I don't want to waste your time. The next question here is list 4 basic processes that are used for purification of tap water. Yes, this is also one of the most important and most expected question you should expect tomorrow. Yes, the basic process we use for separation of tap water, I think, is popular also in junior classes. So that is talking about, there are 3 basic processes, to be honest, but since the examiner wanted to make it 4, so that means you have to explain the processes. Let me do that by rolling my stuff here. So now, doing this, guys, we can say they have sedimentation, fluctuation, addition. Let me just list them, because the first process is called what we call aeration. That is the way Ababio call it. So I want to use what is to your syllabus. I don't want to use what is above your syllabus. So under this aeration is the process of adding of alum. That is what you call coagulation. Sometimes we call it fluctuation for fluctuation. So, but coagulation, basic addition of alum, K to Al to SO4. So that is alum. Then the next process is sedimentation. Allow the stuff to settle in a settling tank. Sedimentation. This is very important, my dear student, because it can come out. Then after that, we have filtration. Then the last process is just what? Disinfection. Disinfection. I hope my spelling is correct. My spelling is like that. So this disinfection is addition of your chlorine, bromine, the chlorine to kill germs, bromine for goiter, iodine for goiter, fluorine for tooth decay. That is just that. So please note that. And these are the process you are to list, and these are the 4 processes you are to list out. Then the next one says, list 3 chemicals that are used for purification of water for tank supply, not true supply, it is tank supply, please. Apologies for the spellings. Now, in continuation to what we have listed, now we can now tell them what we just explained. We can talk about chlorine. We can list the use, but I don't just we are just to list the chemicals. Chlorine is for killing of germs. You can write potash alum. That is for coagulation. That is famous, both in UTME, post-UTME, or any kind of exams you are writing if you are an Indian student. So another one you can write fluorine. Fluorine. Fluorine is for to kick tooth decay. Please note that. So we are just mentioned 3. This is 3. You can write more than 3 if you want. It's not important to you can write iodine too for goiter. So that is that about that. So guys, the next question, because I'm almost there. The next question is we are to define the term solubility, which is also one of the most expected questions you cannot run away from. Solubility and its calculation is going to come out. I can tell you that. Solubility is defined as the amount of solutes that is capable of dissolving 1 dm cube of a solvent at a particular temperature. I don't need to write that. It is common everywhere you go. But let's just write it for the sake of those that don't know it. Apologies, I'm rushing now. I said solubility. Solubility is defined. It's the amount. Let me just write it. Of solute. Amount of solute which is capable of dissolving 1 dm cube of a solvent at a particular temperature. So that is the definition we give to solubility moles per dm cube. Then the next one says, if 1.1 grams of calcium chloride were dissolved in 20 grams of distilled water at this temperature of 20, we are to calculate the solubility of the salt in moles per dm. Calcium molar mass is 40.0, chlorine is 35.5. So doing that, we can apply solubility formula directly without wasting time. Solubility formula is always given as mass of salt. Solubility in moles is always mass over molar mass times 1000 over volume. The marker, please write mass over molar mass multiplied by 1000 dm cube of solvent over volume. So students should keep this simple formula in mind. I know you have learned that in your classes. I'm very, very sure about that. So we can just substitute values. I don't think this one should be issue. The mass of the substance is 1.11. The molar mass of the substance is given in brackets here. Okay, that is CaCl2. You can do that. Everybody should be able to write CaCl2 and calculate its molar mass. Calcium is 40 plus 2 times 35.5 is 71. So on doing that, this is 111 gram per mole. So that's the molar mass, 111 multiplied by 1000 dmK. It's constant, divided by the volume. The volume is at what? So we should be given the volume, which I don't think we have here. We can do it in different ways. Are we given the volume from here? We should be given the volume. Oh, this should be the volume. They solve in 20, not 20 grams. So please, we can substitute 20. So punching calculator, this should be year 1, year 5. So this should be year 1, year 100. That should be something like 0.50 moles per dm3. So please, this is the way it is being done. There are other ways you can do it. You can do it as a number of mole is mass over molar mass. Then you get the number of moles as 0.01 moles. So if you've done that, you now relate. You say if 20 grams of the, I'm using this one as a volume now because it was the one that was dissolved. If 20 grams of this particular stuff, they solve in the number of moles is mass over molar mass, which is this over this. They solve it, if it is gram. Now they solve in what's the answer? Is 0.01 moles, the way you guys were taught. Then you now say 1000 will now dissolve in what? So 1000 of water will now dissolve in what? So on cross multiplication, you can see it will be, we cross multiply this 20s equals to this. So it will also be the same answer as 0.50 moles per dm. So what I'm saying is, if this is written in gram, because it is dissolving, we can say it's the volume of it. So always keep that at the back of your mind. Directly, you can apply the formula for any parameter given. So note that. And you can also use your applied method, which is more like the improvised method, which most of the teachers love to use. Then the D part of the question now, where will I write now? I need to shift this guy up. Then the D part of the question says we should give the name of the reagent. Give the reagent that could be used to distinguish each of the following pair of compound. That is our chemistry of action now. Reagent, that is confirmatory test. That is what we want to talk about. This is a little bit of analytical chemistry, the aspect which we all love. If you are a good chemist, you should love this answer because it's very simple and direct. So we can take the first one as Roman figure 1. This is CH3, CH2. This is CH. You can see, just count the number of carbon atoms. 1, 2, 3, 4. Butanoic acid and 1, 2. This is a C2H5 ethanol. So if you want to, this like a secondary alkanol, and this is just a primary alkanol. I'm not going to that. To differentiate between these, there are different things you can use to differentiate between these. You can use what we call KMNO4. Please note that. From the knowledge of primary, secondary, and tertiary alkanol, talking about the amount that is combined with the alkyl group. Because the methyl group. Methyl is just CH3 here. You have what? You can see you have double of what? Double of this one is combined to what? The OH, the amount of OH is combined to what? 2 alkyl group, 2 of these. So my point is you use KMNO4 from the knowledge of oxidation and reduction reaction of alcohol. You know what I mean by oxidation, addition of oxygen. So we use KMNO4 to distinguish between what we call this is I think this is propane, this is butanol, and this is ethanol. If you don't know that, you can draw the structure from what was given here. Then this one is This is CH3, CH2C, CH double bond, and this is CH3C, CH3C. To differentiate between this one, I think there is a mistake here. One should be triple bond. I think it's a typo error so as to help you, and one should be double bond. That is just it, because from this is not balanced. We can see that it is crystal clear. So everybody should understand, oh, this 1, 2, this is more than this. So be careful about that. One should be triple, one should be double, 1, 2. So this should be triple bond. So please note that triple bond and double bond. So the difference between triple and double bond, we use ammonical copper 1 chloride. So you can use CuCl copper 1 or silver nitrate, AgNO3. So keep that at the back of your mind. Time is not on my side. The last one I'm doing here, CH3, CH2, CH3, this is single bond. This is double bond, single and double bond. You can use the same thing that we talked about. There are a lot of reagents. I'm only picking basic reagents. You can use the same KMNO4 as single bond saturated compound does not have any physical reaction. You know that. You can use bromine, water, Br2. You understand? Bromine itself, bromine water itself, and so on and so forth. You can use K2Cr2O7 and so on and so forth. So please note that the second one is triple and double bond. So that is why only ammonical copper 1 chloride or silver nitrate can distinguish. So ammonica, it will be copper 1 chloride that is dissolved in ammonia. So if you want to write it well, because sometimes Waec can be technical, it should be NH3 slash CuCl. So ammonica copper 1, that is the way we teach. We teach that in classroom, ammonica copper 1 or silver nitrate is directly. So keep that at the back of your mind. So note that. Then this one I told you, this is a primary and secondary alkyl. To differentiate, we use KMNO4. Sometimes we can use what we call an iodo test, iodoform test. This will not have any reaction. This will have reaction. But I don't want to use big reagents. We can use iodoform test using I2 can also be used. That is dipped in what sodium hydroxide. So iodoform test can also be used for those of you that you are writing pursuit here. You can also keep that in mind for the first one to differentiate between primary and secondary alkyl. There are other ways in which I can differentiate. There are lots of ways, but I only limit it with what I believe you might have heard about before. So be careful about this type of question. They are going to come out. So the last but not the least of this slide is the one in which I think I'm drawing. Consider the compound below, CH3CONH2. I'm definitely going to know the functional group. You can see this is very, very simple to identify. This is NH2 and this is OH. So that's that. You have to draw the structure of this compound. Drawing that should not be a problem for us. In fact, why is it not a problem? Because it has been what? The structure element has been written out. Just try writing your C, CH, and whatever, and you draw it out. So just write the first one is CH3, write a C. Then combine your H3, HHH. I hope you understand. The next one is C, O. The next one is NH. N is written here. NH. The next one should be CH. I'm following these guys. CH2OH. That is CH2OH. CH, then OH. So that is the structure you are expected to draw. And you guys know CONH2 is called this functional group. See, CO, this is the functional group here. So CONH2 is called 1, 2, 3, that's 1 H. So 1, 2, 3, that's another. These are H's. We can put it H, H. This is double bond. So please note that CONH2 is so you know carbon is tetravalent. Everybody should note that. So carbon is tetravalent. That should not be a problem for you guys. So guys, that is the right answer for the structure of this. Then the next question says, name the functional group present in the compound. It's very simple. We can see hydroxy group. This is bifunctional, and this is amide group. Amide and hydroxy group. So please, you have to write the two because you can see. I hope you know the difference between amide and amide. amide. Everybody should know amide is just NH2. CONH2 is amide. So, and you know amino acid, that is bifunctional too. Carboxylic and what? And your amino. So that is that about that, guys, about this page. The last but not the least, which is the last page for 2022 preparatory class for chemistry, Waec student, is this. Fine. The last question is question on, I think, redox. You can see I try as much as possible to actually move around different aspects of your syllabus, which I believe if you follow this lead, you are definitely not going to have any problem. So I do this to some extent, for maybe I will leave a lot for you guys to do. We have to explain each of the following terms, each of the following in terms of what? Electron transfer. That means definition in terms of electron transfer. Everybody knows oxidation is loss of electron. We don't need to waste time, right? Loss of electrons. And this guy is a gain of electron in terms of electron transfer. Electrons. So note that, and you can define in terms of addition and removal of hydrogen and oxygen. You can define in terms of increase in oxidation number, and so on and so forth. I hope you still remember this definition, because this is also a very important area that I predict is going to come out tomorrow by the grace of God. So then I said, give one example in each of our 5A1. So example of oxidation. I don't think that one is simple. An example of reduction. Okay, just use any method that comes to your mind. For oxidation and reduction. Oxidation first, Fe2 plus. You can say minus E minus to give you Fe3 plus. Correct. This is oxidation. Oxidation has increased from 2 to 3. But you can also write it like this, because we are saying it is the loss of electron, which is loss of electron here. Fe2 plus to give us Fe3 plus. Then here you are going, if you are writing at the back, it will be plus E minus. So this is also acceptable. So which is mostly what most of you know how to write. So then the other one, think about a non-metal. That what will come to my head now is chlorine. Everybody all know chlorine. So chlorine, Cl2 plus 2E minus to give you C2Cl minus. You can see from 0 to -1 is reduction. This guy has reduced or reduction. So oxidation, reduction is gain. You can see plus. Oxidation is loss. That is why I prefer writing it in this format. So that is that about that. I don't think that one should give us elementary basic definition and interpretation to redox. Should not be a problem. Now, consider consider the following oxidation and reduction reaction equation. We have chromate ion. This is Cl2O72 minus plus NO combined with is given Cl3 plus NO3 minus. I think that should be the reaction, because if you want to talk about redox reaction, we have to what? Then the question writes the oxidation half equation. Oh, it's very simple. Oxidation half equation is we are going to focus on the one that oxidize and the one that reduce. So then we actually focus on what element beside oxygen and hydrogen respectively. So let's write the oxidation half equation first. Please listen to this. Oxidation half equation. The oxidation half equation will be, we have oxidation half equation will now be equals to, trying to check the time. That is what I'm trying to do. Now, oxidation half equation, let's see which one oxidized in this reaction. I think chromium ion has reduced, so it should be NO. So NO is moving from NO is not no, nitrogen oxide, not no. Please note that it's giving us NO3 minus aqueous. Now, what we do is what, to the aspect of to this aspect of oxygen, we try to balance oxygen by adding water. I'm going to add water. And to the aspect of at this particular site, we always love to add what? We balance this side with the amount of what? Hydrogen that is left. Now let's do some kind of calculation. NO3 minus, we can calculate the oxidation state. Now the element beside oxygen is nitrogen. It is 1 here. This is also 1 here. I'm not adding anything to this. That is one thing. So at oxygen, I'm adding water. To actually see the amount of mole of water I'm going to add, just hold on, guys. Now let's calculate the OS of this one. Everybody can calculate oxidation state of oxygen. That is oxygen, that is X of nitrogen, X plus minus 3 times 2 is 6. I'm doing the OX of this one is equals to minus 1. Just see what I want to do. This is X minus 5 is equals to minus 1. X minus 6. So X equals to minus 1. That's 5. So please, we need to know what we are doing. That's 5. So far it is 5. So what I'm trying to do here now is that if this is 5, because oxidation state of an anion is the number of charge on it. So the number of charge on this one is that's 3 times 1. So the number of electrons I'm going to add to this side should be plus 3 electrons. Then to balance this, let's say 2 times 2. Because hydrogen here is this is hydrogen H2O. Okay, it should be 2 moles of hydrogen, then plus 4 H plus. So I think that should be balanced because we have H plus here. That's 4H plus 4 moles. It's balanced. 2 times 2 is 4. And this is the half cell equation of the oxidation half cell. But for the reduction half cell, reduction half equation, that is the chromate ion. We can write Cr2, watch this, O72 minus is now yielding Cr3 plus. Calculate the oxidation state of this so that you know the amount of mole of this one that you are going to add. So that is what I did here. Then you can see the logic I told you. Element beside each of these things is going to be balanced. The chromate ion is beside oxygen. And the first thing here you need to understand is that when you are writing the reduction cell, please always keep it at the back of your mind. Now, at the side of oxygen, I'm putting the hydrogen ion here. So at the right-hand side here, but for the other side of the reduction part, you put it at this side. So please always keep that at the back of my. Here in this case, it is this is 7 times 2. 7 times 2, because oxidation state of this one is -2. So 7 times 2 is 14. So that means I'm going to have 14H plus here. Then moving on, before I add the electrons to it, I have to also balance this one. So this guy is a Cr2, 2. So that means I have to put 2 here. That is the element beside oxygen, which is what I did there as well. Nitrogen is 1. It's 1 here. That's why I'm not putting anything here. So keep that in mind. You can watch how to balance redox reaction if you don't know that. So this is now 6. 2 times 3 is 6. We are almost there. Then what I do here is not to know the number of electrons. I'm going to put, if this is 6 electrons, so I'm going to have, so I balance this side with water, you know that. So plus H2O. Then the hydrogen is 14. If I write H2O, for me to get 14, that will be 7. If I'm not mistaken, because 7 2s are 14. Then I balance the number of electrons. 2 times 3 is 6. It's a 6E minus. I think this is balanced now. So what we do, the logic things, the way I teach in shortcut way is if you are writing oxidation to the right-hand side, this is where you have your H plus. But if you are writing reduction, you have the H plus to the left-hand side. That is the logic for acidic medium. But if it is basic medium, you know, we cannot be having proton. We have to change it to what? To that. Then another thing you keep in mind is what you add water to the left-hand side, add what? Hydrogen ions to the what? Right-hand side. First of all, balance the compound beside oxygen first. The compound beside them we switch to. Look at here, it is chromate. Here it is Cr2. So that is why I have to put 2 here. This one is 1. 1 was here. I hope you understand this. Then after that, I will add water to this side of this. I add water to this side of this. So if I check the stuff and if I do that in sequence, I'm going to balance this by also adding hydrogen to this side and hydrogen to this side. How did I know that it is 14 hydrogen I'm going to add here? What? 7 times 2, I know that what is going to give me 14. In this case, I have 3 times 1, that is 3 plus 1 hydrogen ion that was given in the question to make 4. That is why I have 4H plus at this side. So this is what you are expected to write, and that is how to write that. And if you are not so good in this type of question, that is why you have opportunity to pick the areas which you know very well. So not to waste our time because of our time, they said determine the overall balance equation for the two reactions. So now, when you've written this one, to balance the reaction is very simple. Just take the numbers of moles, then you balance. If you want to do that, you can just look at this very well and watch it closely. What you need to check here is just, okay, fine. How do I balance? This guy is 4. This guy is 14. Okay, what I can do here, I think it's very simple for me to do a kind of simple mathematics. Maybe for me to have equation that will balance, what I will just do here, my dear students, is to leave this one the way it is. This guy is the electrons I'm focusing on. This is 3, this is 2. Let me just multiply this equation by 2. I'm doing a kind of math. So if I multiply this equation by 2, this will be 2 times 2. That is 4H2O. I need to be fast. Time is not on my side. This thing will stop automatically. Plus 2 NO. I am multiplying the first equation by 2. You give me 2NO3 minus. Sorry guys. Plus 6E minus. Then plus 4 2s are 8H plus. So I'm going to add it with the second equation, which you can see here, Cl2O7 minus 2 minus plus 14H plus 6E minus to give us 2Cl3 plus 7 of water. So on simplification, this gets cancelled out. You can see what I'm doing. When you combine, what you are going to have left will now be equals to, I want to write the product here now, will now be equals to Cl2O7 2 minus, I'm writing from here, then plus 14 minus 8 as 6H plus, then electrons plus this gets cancelled out, electron gets cancelled out. You can see that no more electrons. Then plus the nitrogen here, that's nitrogen oxide 2NO will now give me 2NO3 minus, then plus 2Cl3 plus, then plus 7 minus 4 is 3, and plus 3H2O. H2O. So this will be the answer to that for the overall reaction for that. It's very simple. If you have learned the concept, it's a very simple question. And the next question is a C type, which is the last. Describe briefly the extraction of tin from its ore. Now, extraction of metals from its ore is by electrolytic, by reduction from the ore. The ore of tin is called we call it Besima. You know, ore of tin, you have cassiterite, SnO2. So most of the ore is from SnO2. I will use that as my own explanation. Time is not on my side. I am sorry, my dear student. I'm very sorry. So how do we do that? Under the process of extraction of metal from its ore, or extraction of metal, it is named metallurgy. You can keep that on the back of your mind, especially the A-level student. So how do we do that? It is what? The first thing is what? We are to extract it from the concentration of the we are going to crush, process and crushing. After crushing, we clean, washing, then roasting. Now, these are the 3 processes we do on what in metallurgy. So what we do is what? We crush it. Crushing is what? The concentration of the oil is going to crush and it's going to be washed with water. After it is being washed with water, it's going to be roasted. And why do we roast it? Is to remove impurity. Roasting is done to remove impurity. So keep that in mind. So I told you the oil is SnO2 cassiterite, which is common. So impurity, when we roast it, we add it with charcoal. That is what we use, charcoal or carbon, you know, reduction with carbon or carbon monoxide. That is the way you see it in your Pabio and all the textbooks you guys are using. So what we use to obtain the pure form is from limestone. Look at the way we write the equation of reaction is SnO2. So we have to write the balance equation, which is the next question now. SnO2 will be what? Will be mixed with charcoal. That is charcoal is carbon, which is a solid form. This is also solid impurity. So it can be in two forms. It can give you tin directly plus carbon monoxide. You can also write it that it is giving you SNO2 plus CSN. But this is most likely what I will write for now for your level. Then after doing this, this that is obtained will now be combined with oxygen. This is solid to give out SNO2. So this is the equation of reaction. Then it will now be reacted again with what? With chlorine, which is chloride ion, which will give you SnCl4. So note that these are the process of what we have according to the question. I'm just rushing because I don't want us to waste time. So these are what we are supposed to do, and I think I've done them in what? In accordance, in series. I have done this. Describe briefly how it is done. You can write it in language. It is obtained from the ore. The ore is cassiterite. I hope my spelling is correct. And if it is not correct, please you can change it. Then the next one says write a balance equation for the reaction. I said this is the one I will write for now. Then after that, you are writing balance equation of tin with oxygen, which is this, and with chlorine, which is this. And that is why I said I've done it in accordance. Then the next one says state two uses of tin. Please, I'm rushing because of time, nothing more potential. These are simple stuff. Uses of tin, you can write a lot of what? Tins are used in making alloy. You know that. Making of alloys, I think that is very good. They're also using coating of metals. I think that one is also good. That comes to my head. Coatings of pipe, metal, anyhow. Coatings of metals or coating of metals. Example of metal you can coat with tin should be steel, because sometimes the question can ask you to list. And you can also use tin to coat iron too. So which is most important. Now the next one says just two. You can list more than two. As in you can still write more. There are more use of they are used for making cans. Tins are used for making cans. You can also write that too, but only two is needed. State one condition necessary for the reaction 5C3. Why is 5C3? Reaction with oxygen. This reaction requires high temperature, please. High temperature. Extraction of metal, extraction by reduction process always require very high temperature. In fact, you can write very high and not, you understand. So very high temperature is always needed for the reaction to take place. So students, this is what I can do for now, guys, for your revision for chemistry questions, theory part. So you can always send a question. If you have any question you want me to solve for you directly to me on my WhatsApp page and Facebook page or Telegram page, or directly to my mail, I will attend to them. So we are going to stop here. If you find anything interesting on this particular page, you can consider subscribing to it and tell your friends about it. We'll see you soon, and I wish you best of luck in your exam that is coming up tomorrow on chemistry. Make sure you do it well, and make sure you don't make silly mistakes. Focus on the ones you know. You are to select. Read instruction. Don't do more than what the examiner asks. Be different. Make sure you are different to get your A+. Wish you best of luck. Bye for